2 on dividing radicals, rationalizing denominators. And before we get started, I wanted to talk about the key piece of vocabulary that you're going to need to understand in order to be okay with today's lesson. And the term we have is the word conjugate. Does everybody see where we're at? Looks like you do. And a conjugate, quite simply, is just a tool, like a hammer or a screwdriver. It's a tool we can use to get rid of radicals on the bottom of a fraction. At least that's what we're going to use it for. Thank you. So it's a tool we can use to get rid of radicals on the bottom of a fraction. Honestly, for our purposes, it's basically going to consist of the same numeric values in the original denominator, just with a different sign, opposite sign, in between. So you see I have some for instances up there. Those are the ones you wrote down in your notes. For instance, we have the square root of 2 plus 1. The conjugate of the square root of 2 plus 1 is just the square root of 2 minus 1. Likewise, you know, if I gave you something that looked like the square root of 3 minus the square root of 5, and I asked you for the conjugate pair for that guy, the conjugate of the square root of 3 minus the square root of 5 is just the square root of 3 plus the square root of 5. Do you see how it's the same numbers? Different signs in between. You don't change the other sign at all. Same numbers, different signs in between. So with that, I'm going to have you flip back to the previous page. There's another chart that we're going to take a moment to fill in. Why this serves as a tool is because it allows us to get rid of radicals as they appear on the bottom of a fraction. So what I'm going to do is just show you in this chart how multiplying by a conjugate actually produces a product that is radical-free. So yesterday we talked about how, like, if you just had the square root of 3 on the bottom of your fraction, you could just multiply the top and bottom by the square root of 3, and then poof, the radical went away and you got 3. Today's problems are a little bit different, a little bit more to them. There's actually terms hanging out in the bottom of your fraction. In other words, things separated by a plus or a minus sign. When there are terms in the bottom of your fraction, you're actually going to use a conjugate to help you get rid of that radical. So you'll see here that what I wrote down is if the square root of 3 plus 1 were in your denominator, you would have to multiply the top and bottom by the square root of 3 minus 1. Same numbers, opposite signs. Here's how that helps you get rid of the radical. Essentially, we would have to multiply these two quantities together. And when you multiply two binomials together, that's a FOIL problem. So we're going to FOIL those two things. So we're going to take the square root of 3 times the square root of 3. Square root of 3 times the square root of 3, that's just 3 from the previous row on your table. Square root of 3 times the square root of 3, same as the square root of 9. Square root of 9 is just 3. My outers is going to be the square root of 3 times negative 1. That's negative square root of 3. Your inners is going to be 1 times the square root of 3. That's the positive square root of 3. And then your last is going to be positive 1 times negative 1. And do you see what happens because we used opposite signs in the parentheses? What happens is your outers and inners cancel, and the radicals went away. So we have 3 minus 1, which is 2. So you end up obtaining a radical-free denominator out of that. It would work if my original symbol or sign or operator were a subtraction or minus sign as well. So you'll see there I have the square root of 2 minus 3. The conjugate pair for that would be the square root of 2 plus 3. If I want to multiply these two things together, it's just a FOIL problem. You would do the square root of 2 times the square root of 2, that's 2. Your outers is positive 3 root 2. Your inners is negative 3 root 2. And your last, negative 3 times positive 3 is negative 9. You see that your outers and your inners cancel because they're the same value but opposite sign. So what you're actually left there what you're left with is 2 minus 9, and that is negative 7. So it's radical free. Pretty nice. So over the past couple minutes, it's my understanding you now know what a conjugate is. Same numbers, opposite sign in between. So with that, I wanted you to think about, thank you. Aw, don't look. I wanted you to give me the conjugates for those two pairs. A little bit of independent practice here for a sec. We have bang. So you're identifying the conjugates for those two. Okay. So bird's eye view on that looked pretty good. Conjugate of the square root of 5 plus the square root of 2 is the square root of 5 minus the square root of 2. And then the conjugate for the square root of 3 minus 4 is just the square root of 3 plus 4. Okay, so now let's do some. Oh, I see what I did. I pulled up the slideshow that was already done from my previous session. Back to this. Maybe. So here in example 2, we are asked to rationalize these denominators. Now all these problems up here are bad because they have square roots in the bottom of our fractions, right? You're not allowed to have those. So our mission is to get rid of those radicals that appear in the bottom of the fraction. We have to rewrite these exact same expressions in a different way. So what we're going to do today is use the tool known as the conjugate to do that. So step 1 is to multiply the top and bottom by the conjugate of the original denominator. So what we're going to do is we're going to multiply the top and bottom of this fraction by the square root of 3 plus 2. Remember, what you do to the bottom of a fraction, you have to do to the top. Essentially, the square root of 3 plus 2 over the square root of 3 plus 2, that number right there is just 1. So I'm not really multiplying my original fraction or ratio by a number that would change the original value of the problem. I'm just multiplying it by 1, keeping the value of that fraction the same. What happens when you end up multiplying the top and bottom by the conjugate is you end up with a little mini math problem in your numerator and then a little mini math problem in your denominator. My little mini math problem in my numerator is a distributive property problem. When I multiply fractions, I multiply straight across. So I have to take 2 times the square root of 3 plus 2. When I distribute that 2 in, I get 2 times root 3 plus 2 times 2, that's 4. So that's what my numerator is going to look like. And as we executed in the table just a few moments ago, when you go ahead and work out the denominators product, you always end up foiling when you have terms on the bottom of your expression there. So when I multiply the square root of 3 minus 2 times the square root of 3 plus 2, that's a FOIL problem. So that's why I taught you this last week. We have to do the square root of 3 times the square root of 3. That's just 3. Square root of 3 times the square root of 3 times positive 2 is 2 root 3. Inners is negative 2 root 3, and my last is negative 4. And then do you see that? The 2 root 3 and the negative 2 root 3 ran away. So what I have is 3 minus 4 there. 3 minus 4 simplifies to be negative 1. So I put my negative 1 in the denominator there. And then what else is kind of cool about this one is that you could just divide that negative 1 into both pieces. So the best answer for this one, to pretty it up a little bit, looks like negative 2 root 3 minus 4. Negative 2 root 3 minus 4. So that's the process. Just to summarize, step 1, you identify the conjugate. Step 2, you multiply top and bottom of that fraction conjugate. You usually have to distribute through the top and then FOIL through the bottom. Reduce at the very end. All right, we're going to do that again. A couple more times today, right? For a little reinforcement. But I'm going to follow the exact same step-by-step process each time. So the first thing I have to do is identify the conjugate. And I know I have to do that because there's two pieces to the bottom of this fraction. The only way to get rid of both of those radicals is to multiply the top and bottom by the conjugate. So that's that. You always end up with like a little mini math problem in your numerator and a little mini math problem in your denominator. In the numerator, we multiply fractions, you multiply straight across. We have the square root of 3 times the square root of 5 minus the square root of 2. In the denominator, we have the square root of 5 plus the square root of 2, bless you, times the square root of 5 minus the square root of 2. I'm going to distribute. So we have the square root of 3 times the square root of 5, that's the square root of 15. Bring down your minus, and then we have the square root of 3 times the square root of 2. That's the square root of 6. Those can't be because they're not like radical parts. And they can't be simplified either. No perfect squares go into 15. No perfect squares go into 6. For the denominator, I'm going to FOIL. So I have to take the square root of 5 times the square root of 5. That is 5. Outers is going to be the negative square root of 10. My inners is going to be the positive square root of 10. And my last, square root of 2 times the square root of 2. One positive, one negative, that'll be minus 2. And then these things go away. And that's by design. That's because we used a conjugate. So that's awesome because now our denominator is radical free. 5 minus 2 is 3. So our numerator is the square root of 15 minus the square root of 6. And then this is all over 3. Does anybody have any questions about that? Remember, you don't write it down unless you understand it. So if you're, why did those square root of 10s go away? You know, you got to ask about that. If you don't know where the square root of 10 came from, you want to ask about that. Something has to cancel, right? Those radicals have to go away. Now, is it always those two in the middle? Depends on the kind of the order, the way the denominators are written. If the radicals don't go away, that's when you know you have a problem. So just make sure those go away, you know. All right, let's do another one. 2 more. Like rationalizing wind sprints. Ooh, that's loud. Okay, so we have the square root of 6 over 2 minus 5 root 2. Process is exactly the same. We're going to multiply the top and bottom by the conjugate. And the conjugate for this guy, 2 plus 5 root 2. And that creates for me a little mini math problem on the bottom and on the top. So I have to work out my numerator, work out my denominator. So I have the square root of 6 times 2 plus 5 root 2. And I would distribute that square root of 6 in. Square root of 6 times 2, that's just 2 square roots of 6. And then the square root of 6 times 5 root 2, that is 5 times the square root of 12. Square root of 12, that catches my eye. I don't know if it caught yours, but this does break down to 4 times 3. So I would simplify that. If you don't do it now, you'd have to do it later. So I would do it now. And then you folks know that this would then be 5 times square root of 4 is 2 square root of 3. Or you could say that this is 2 root 6 plus 10 root 3. And then those aren't like radicals, so we can't combine them. Those are done. Anybody have any questions on how I simplified the numerator? Or how I expanded the numerator, rather? All good? Right. Nice. Now I got to work out the denominator, right? It's always a FOIL problem. Well, when there's terms in your denominator. It wasn't a FOIL problem last night, was it? So my first 2 times 2, that's 4. My outers, 2 times 5 root 2, 2. Inners is negative 10 root 2. And my last, 5 times 5 is 25. Square root of 2 times the square root of 2 is 2. So what I'm looking at now is my outers and inners do cancel, and then I have 4 minus 50 to simplify. 4 minus 50 is negative 46. So I would go ahead and take my numerator, put it on top there. Stuff open up here. So that's my numerator, and then my denominator was just negative 46. And then when I piece those together, I'm like, oh, wait a second. I see that every term, every single one, every term is even. Do you see that? 2, there's a 10, negative 46. All those are even. So I can reduce because they all have a common factor. Since they all have a common factor, I am going to go ahead and reduce it down by taking out that factor of 2. So if I take 2 out of 2, that's just 1. 2 out of 10, that's just 5. And then negative 46 divided by 2, negative 23. So the best answer for this is actually the square root of 6 plus 5 root 3 all over negative 23. So it's important to remember to reduce your answer to lowest terms when you're all done. Okay, one more. This time I put a letter in it. So I have 1 divided by the square root of x plus 2 there. So again, you got to rationalize the denominator. You can't have a square root in the bottom of your fraction like that. So we would start by multiplying the top and bottom by the conjugate. And then when we multiply fractions, you multiply straight across. There's not really a whole lot to show in the numerator. We're taking 1 times the square root of x minus 2. That's just the square root of x minus 2. So that's actually pretty easy to do. Not really anything to show. In the denominator, however, we have a FOIL problem to do. We have to take the square root of x plus 2, multiply it by the square root of x minus 2. Square root of x times the square root of x, that's the square root of x squared, right? Which is just x. Minus 2 root x for your outers, plus 2 root x for your inners, minus 4. Your outers and inners cancel, and what you have left is x minus 4. That is done. Now you can't reduce the 2 and a 4 this time around because in this particular answer, not every single term has that factor of 2. It was different than the one before it. The one before it, or maybe after it, depending on how I screen captured here, all of these numbers had that common factor. Do you see that? Now here, only the 2 and the 4 have that common factor. So we cannot, where'd it go? I lost it. There it is. So we can't reduce out that factor of 2 and 4. That's done. All right, so now you get to try. You have 1 independent practice problem left in the section. I would like you to try that. You have to be able to do that one problem before I give you your problems for tonight. And just to wrap up this guy, your answer is up here on the smartboard, so you kind of want to check it. If you didn't get it right, flag me down. I'm going to walk around and help you guys out a little bit. If you're good, then you can start on your assignment for tonight. You're ready. You do have 12 problems. on your dividing radicals worksheet. What's up, John? You just need some help. Number 1, you just multiplied the top and bottom by the square root of 5. Oh, yeah, there's not really a whole lot of work to show. I thought you meant in the practice. No, you're good. Yeah, I got to walk around and check off your assignment from last night, so please make sure that's out on